Welcome everybody. In today's video, we're going to talk about graphing compound inequalities using the three-line method. But before we begin, we need to review some of our symbols. For example, when the endpoints are not included, this is when we use greater than or less than, then we use the parentheses. If the endpoints are included, when we use less than or equal or greater than or equal, then we're going to use the brackets. When we're dealing with infinity, whether it be negative or positive, there are no endpoints, and we're going to use the parentheses. The union operator combines elements in either set, and this is used with OR statements, where the intersection operator combines numbers that are only in both, and this is going to be used with the AND statements. So let's jump in and look at some examples. Here we have x greater than -2 and x less than or equal to 4. Now, in certain cases, this could be written as a single expression. For example, -2 less than x less than or equal to 4. Well, let's talk about the lines we see down below. So I have three lines, and the first line is going to be for the first inequality. The second line is going to be for the second inequality. And that third line is going to be for either the AND or the OR statement, and it's going to be our solution. Now we also see two vertical lines. The one on the left will be for the smaller number, and the one on the right will be for the bigger number. So here we have -2 and 4. Well, -2 is less than 4, so it will be on the left, and then the other one will be 4. So let's take a look at our first inequality, x greater than -2. Here the endpoint is not included, so we're going to use the parenthesis, and since it's greater than, we're going to shade everything to the right. This is going to be all the points between -2 and infinity. Our second inequality, we have x less than or equal to 4, and the endpoint is included, so we're going to use the bracket. And since it's less than, we're going to shade everything to the left. This is going to be all the points from -infinity to 4, including 4. Now this is the AND operator, so we're looking for the numbers that are in both the first and the second line, or the overlapping. Well, we can see that we're going to get the -2 to 4 and shade in between. Again, we do not include the endpoint on the -2. So when we use our intersection operator, we're going to get just open parenthesis -2, comma, 4, close bracket. Notice in this case we had the AND statement with the inequalities going in opposite directions, and there was an overlapping. In our next example, we have x greater than -2 and x greater than or equal to 4. Again, we're going to go ahead and label our vertical lines -2 and 4, and take a look at our first inequality on the first line. X greater than -2 does not include the point -2. So we're going to use the parenthesis, and then we're going to shade everything to the right. So this is going to be all the points in between -2 and infinity. In our second inequality, x greater than or equal to 4, it does include the endpoint, so we're going to use a bracket at 4, and we're going to shade everything to the right. This is going to be all the points from 4 to infinity, including 4. Again, we're using the AND operator, so we're looking at the overlapping. Well, we can see that the second line is a subset of the first line, so we're only going to be using the second line. So again, that's the points from 4 to the right. And when we use that intersection operator, we get the second line. So here, it's all the points from 4 to infinity, including 4. In our last AND example, we have x less than or equal to -2 and x greater than 4. Once again, we'll label our vertical lines -2 and 4, and take a look at our first inequality. Here we have x less than or equal to -2, so we do include the endpoint. We'll use the bracket, and since it's less than, we'll shade everything to the left. This is going to be all the points in between -infinity and -2. In our second inequality, we have x greater than 4. Here we're going to use the parenthesis, since 4 is not included, and shade everything to the right. This is going to be all the points between 4 and infinity. Now this is the AND operator, so we're looking for the numbers that are in both sets. Well, that's the overlapping, but here we can see there is no overlapping. So this is an example when there's nothing to shade on the third line. And when we use our intersection operator, we're just going to use the no solution symbol. Or sometimes we'll just write no solution. Okay, now we're going to look at some OR examples. Here we have x greater than negative 2 or x less than or equal to 4. Again, we'll label our vertical lines negative 2 and 4 and take a look at our first inequality. X greater than negative 2 does not include the endpoint negative 2, so we'll use the parentheses, and it's greater than, so we'll shade everything to the right. This is going to be all the points in between negative 2 and infinity. Now our second inequality, x less than or equal to 4, does include the endpoint 4. So we're going to use the bracket, and we're going to shade everything to the left since it's less than. And it's going to be all the points from negative infinity to 4, including the endpoint. Now again, this is the OR operator, so we're going to combine these sets. We're going to look at the combination of line 1 and 2. Well, we can see that between the two of them, we actually cover all the real numbers. So we're going to shade the entire line. And when we use that union operator, we'll see we get everything from negative infinity to infinity. And that'll be our solution. Sometimes we can write all real numbers, or we use the all real numbers set symbol, the bold R. In our next R example, we're going to look at x greater than negative 2 or x greater than or equal to 4. Okay, so here in our first one, we do not include the endpoint, and we're greater than, so we go all the way to the right. Again, this is all the points between negative 2 and infinity. In our second inequality, x greater than or equal to 4, we do include the endpoint. And we also are going to shade to the right. So this is going to be all the points from 4 to infinity, including 4. With the OR operator, we're looking to combine the two lines. So we can see that the second line is actually a subset of the first line. So this is going to be a copy of the first line, or from negative 2 to infinity. All right, in our last OR example, we're going to take a look at x less than or equal to negative 2 or x greater than 4. Again, after we number our lines, we'll look at our first inequality. This one has x less than or equal to negative 2, so negative 2 is included. We're going to use the parenthesis, and we're going to shade everything to the left. This is going to be all the points from negative infinity to negative 2, including the point negative 2. In our second inequality, we have x greater than 4. This is going to be a parenthesis at 4 and shading everything to the right. So this is going to be all the points in between 4 and infinity. This is the OR operator, so we're looking for the combination of line 1 and 2. Well, here, there's no overlapping, but we're just going to repeat what we see in line 1 and add it to what we see in line 2. When we union them together, this is what we get. Okay, so that concludes our examples, 3 AND examples, 3 OR examples. I hope you learned something today, and I recommend that you follow this up by looking at some examples in your book. Thank you, and have a great day.